Hey there, it's the Math Doc back again, and we're continuing on the path of equations. In the previous video, we defined an equation and showed some examples, and I'll link to that in the description below. And in this video, we're going to discuss the addition and subtraction properties of equalities. So if you're new to this channel, please subscribe. And in any case, thanks for joining me again here. So what are the addition and subtraction properties of equalities? Well, these are properties that help us manipulate equalities. So let's look at this first one here on the top. We have A equals B, right? That is an equality. We have an equality sign between the two sides. So if A equals B, then we can add the same number, which is here signified by C. We can add the same number to both sides of the equality, and the equality will still hold. So if A equals B, then A plus C equals B plus C. And to demonstrate this, I have here an old school example with items. So here we have birdies. We have a picture of 3 birds here on top. So we can write this as an equality. 3 birds equals the number 3. Now we're adding another bird is landing here, right? So in order to keep this inequality, I'm going to have to add another number here. Since we're adding one bird, I will add the number 1 here. Now what do we have here? We have 3 birds plus 1 bird. That gives us 4 birds here, right? 1, 2, 3, 4. And on the other hand here, 3 plus 1 equals 4. Okay, so and we added this diagonally. So now we have 4 birds equals 4. So we remain with an equality that still holds. So again, we added 1 bird here, right? And we added the number 1 here so that this equality continues to hold. It's as simple as that, but it's a really significant tool when we come to manipulate equations. What is the subtraction property of equality? Well, it's very similar, except instead of adding, we will subtract. So if we have A equals B, then we can subtract the same number C from both sides of an equality. We have A minus C equals B minus C. And here again, we have a demonstration with items. So here we have 1, 2, 3, 4, 5 apples. So let's write the equality. The apples equal 5. Now someone came and ate 1 apple here, so we subtracted 1 apple, right? So we have to subtract 1 from the other side too. We remain with 4 apples on the left, and when we do 5 minus 1, we get 4, right? And so again, we can write the equality. So by adding or subtracting the same number, so remember, it has to be the same number from both sides. Okay, that's the important point. Both sides of equality. We keep this equality. The equality remains true. Let's look at some examples. So in our examples, what we will be trying to do is something called isolating variables. And as we move along with the treatment of equations, it will become very clear why we want to isolate variables. But the idea is that we want our variable, which is usually given by x or another letter, we want x to be isolated or alone on one side of an equation. So let's look at these examples and slowly go through them. Let's look at this first one here. X minus 5 equals 13. So in order to figure out what x is, what we'd like to do is isolate it again on one side of the equation. How can we do that? Well, we can add or subtract a number from this equation. And when we say from the add or subtract to the equation, we need both sides of the equation. Well, let's try to add the number 5 to both sides of the equation, right? We're going to guess or not guess just by seeing that we have x minus 5 that it would be a good idea to add 5 to both sides of the equation. So on the left-hand side, we have x minus 5 plus 5. And on the right-hand side, we have 13 plus 5. And we know that we've added the same number to both sides, so we can put an equal sign here, right? The equal sign remains because we were careful. Now, on the left-hand side, we have minus 5, right? Plus 5. And these two will cancel. Minus 5 plus 5 is just 0. So we remain with x equals, what is 13 plus 5? It's just 18. So what does that mean? It means that we actually solved this equation, and now we have the answer that x equals 18 will satisfy this original equation we started with. This is our answer. So when we can now check our answer, okay? What we'll do is we'll take x equals 18 and put it in our original equation. So we have 18 minus 5 equals 13. Well, on the left-hand side, we have 18 minus 5, which is just 13. So we get 13 equals 13, and that, of course, is correct. Okay, let's move on to our second example. X plus 5 equals 13. It's very similar to our first one, except here we have a plus sign. Well, with this plus sign, that's an indication that we should use the subtraction property. Let's try subtracting 5 from both sides of this equation. So we have on the left-hand side x plus 5 minus 5. I'm going to make a line between the two examples so we're not confused. And on the right-hand side, we have 13 minus 5. And because we were careful and subtracted the same number, we can transfer the equality sign from the original equation to this new one. Again, we have 5 minus 5, and those cancel out. And we remain with x equals 13 minus 5. What is 13 minus 5? It is just 8. And so our answer here is x equal 8. Let's check, and it's always a good idea to check our results. Let's put it into the original equation. So we have x plus 5, which is 8 plus 5, equals 13. What is 8 plus 5? 8 plus 5 is 13. So we get 13 equals 13. And indeed, that is correct. So we have looked at two examples. One is uses the subtraction property. The other uses the addition property. Let's look at these other two examples. They're very similar, but here we have a minus sign or a negative sign before our x. So it might be a little more confusing, right? Let's add x to both sides of this equality. So we'll add x to this side and we'll add x to this side. Okay, so we get 15 minus x plus x equals 9 plus x. Why is this okay? We added the same number. It's a variable, it's x, but it's still the same variable on both sides, so we're okay. On the left-hand side, these two x's, right, will cancel. We have negative x plus x, so they cancel. So we remain with 15 equals 9 plus x. Okay, so now we have a positive coefficient before our x, but it's still not isolated. How do we isolate it? Well, we want to basically get rid of that 9. How do we do that? We subtract 9 from both sides of this equation. Okay, so now we have 15 minus 9 equals 9 plus x minus 9. On the left-hand side, we have 15 minus 9, which equals 6. And on the right-hand side, the two 9's cancel, right? We have plus 9 and minus 9, and we remain with x. And we can get the result that x equals 6. Should we check this? Yes, let's check it. Right down here, 15 minus x minus 6, right, equals 9. 15 minus 6 is 9. So indeed, 9 equals 9, and we are okay. That was our third example, and we're finally at our last example, where again, our x here is part of the equation, and we want to isolate it. How do we isolate it here? Let's try to subtract 15 from both sides of our equation. We have 15 plus x on the left-hand side, so in order to isolate x, we just have to take away that 15. So 15 plus x minus 15 equals 9 minus 15. Okay, on the left-hand side, the two 15s here, 15 and minus 15, cancel, right? And we get x. So we've isolated x on the left, equals 9 minus 15. 9 is smaller than 15, so we'll get a negative number, but it's still a number. 9 minus 15 is just negative 6. So we get x equals negative 6. Let's check this. Okay, 15 plus x, so plus negative 6, equals 9. That is just 15 minus 6, right? Positive with a negative is just negative, equals 9. And indeed, 15 minus 6 is just 9. So 9 equals 9, and we are okay. So hopefully these examples showed you how we work with the addition and subtraction properties, and we'll go on to look at a word problem in our next slide. So when we work with word problems here, we're actually going to have to build our equation, and we'll go work through this real slow so you can follow and understand the process. So let's look at how we build an equation and isolate variables in a real word problem. So here's the problem. After Sarah grabbed 2 of Sam's cherries, he was left with 7. How many cherries did Sam originally have? Okay, so what do we know? We know that Sarah grabbed 2 of Sam's cherries, and that he was left, after she grabbed them, with 7. Now we can guess how many cherries he had, but let's build the equation. So the question is, how many cherries did Sam originally have? That is our question. That is our unknown variable. So x is going to be number of original cherries. Okay? Or rather, it's the original number of cherries. The cherries don't have to be original. Sarah grabbed 2 of these cherries. So we had x minus 2, right? She grabbed 2 of them, equals 7. He remained with 7. Let's go through this again. Let's look at this equation again. This was the original number, right? We had an original number of cherries, x. We took away 2, right? Sarah grabbed 2 of them. And what we remained with at the end was equal to 7. Okay? So we started with an unknown number x, and after 2 were taken away, we remained with 7. And that is kind of our story here. Okay? We wrote down our word problem as a sentence in a mathematical sentence using a variable, which was the basically the value that we were asked about, and the other 2 pieces of information that we got, that Sarah grabbed 2 and that Sam remained with 7. Okay, so this is our equation, x minus 2 equals 7. Let's solve this by isolating our variable x. So we will use the addition property here. We will add 2 to both sides of this equality. We have x minus 2 plus 2 on the left equals 7 plus 2. Why is it equal? Because we've added the same number 2 to both sides. So x minus 2 plus 2 is just x because the minus 2 and 2 cancel, and x equals 9. So our answer is Sam originally had 9 cherries. Okay. We will have another example where we go through this process slowly, and we will have many more videos emphasizing how to build an equation out of a word problem. Our next problem, word problem, will be similar, and we're going to do the same thing. We're going to carefully build an equation, and then we will solve it by isolating our variable. So let's read it. Daniel read 37 pages this morning in his book and reached page 62. So we know he read 37 pages. I like to underline or at least emphasize the numbers I know. So he read 37 pages this morning and he reached page 62. The question is, how many pages did he read before this morning? So that is what we want to answer, and so that will be our variable x. So x is the number of pages he previously read, right? Okay, so let's write our mathematical equation here. Let's write this story in numbers and variables. So let's start with how much he read before. He read X pages before this morning. Let's add to that the number of pages he read this morning. That's another 37. And we know that he reached page 62. So that is the total number of pages he read. So the total number here, right, total, equals before plus this morning. So this is the way we formulate this word problem into a mathematical sentence. So this is our equation for x. And now in order to figure out what x is, we're going to use the properties of the equality to isolate x in order to get our answer. So let's write it up here. X plus 37 equals 62. Okay, we want to isolate x, so we know by now that we should subtract this number from both sides, right? We should subtract 37 from both sides of this equation. We get x plus 37 minus 37 on the left equals 62 minus 37. So x plus 37 minus 37, so now we have 62 minus 37. Let's do this. Let's write this down up here somewhere. 62 minus 37. So we have 2. Let's borrow 1 from the 6. That's 5. So we have 12 here. 12 minus 7 is just 5. 5 minus 3 is 2. So we remain with 25. So we have x equals 25. So the answer to our problem is that Daniel read 25 pages prior to this morning. Okay, we will work out many more examples in the following videos. We will go through the other properties of equalities, and we will practice this a lot so that it really sinks in. Again, thank you for joining me for this video. If you have any questions or specific problems you'd like me to respond to, or to even cater a video around, I'll be happy to. If you're new to this channel, please subscribe, and we'll see you next time.